Welcome to Cybersecurity Workshops. We're continuing our discussion of the command line interface, and so in this session we're going to talk about zipping and unzipping files. So we're continuing Matt Vogel's course. Matt is a faculty member at Tidewater Community College, and in Module 2 of his Introduction to Command Line Interface course, we have gone through the description of the file system and all kinds of different commands that help us do things with files and directories. And today, in this session, we're going to talk about zipping and unzipping. So we'll dive right in here. Okay, understand how to zip files, understand how to unzip files. Really, this, when you say zip and unzip, that really you're usually using that as you know, a pseudonym for the term compress, right? We're going to compress and decompress. And why would you want to do that? Well, we'll talk about a couple of reasons to do it. Certainly file compression is important when you are doing things like backing up files. Like if you're going to back up a file system and store it off-site, you want to make that backup as small as possible. And there are different compression algorithms that will squeeze down the size of a file. And there are different kinds of compression. And I'll just touch on this very briefly here. So there's this notion of lossy compression. So there's lossy compression and there's lossless compression. So lossy compression is when you are going to do something like you know, put a video file or an audio file available on the internet, for example. And you want that video or audio file to be accessible to people that maybe don't have a super high bandwidth internet connection, and also, you know, the quality of that video or audio recording is, you know, maybe it's okay for it not to be perfect, right? So sometimes you look at a YouTube video and it's a little bit grainy because you don't have a great bandwidth, you know, internet connection, or maybe an audio recording sounds a little bit funny because your connection isn't great, and that's because the file is being compressed using one of these lossy compression algorithms, and so lossy means you're losing something in the translation, right? So you lose a little bit of quality, but you make the file much smaller, and that allows you to make it available to more people with less you know, with lower bandwidth internet connections. You'll see that too with image files. So you can make a JPEG image, for example, it's very small, but if you you know, expand that thing on your screen, you'll see that when you make the size of the file smaller by compressing it, the quality of the image is reduced significantly. The kinds of compression we're going to be talking about today are lossless compression, right? So we want to make the size of the file smaller, but we don't want to lose anything in that transition. So when we expand the file again, the file is exactly like it was when we made it smaller. And so when we use lossless compression, the amount of compression you're going to achieve is much less, because you can't lose any data in that process. But you can certainly reduce the size of files using these lossless compression techniques, and you know, I'm not going to talk much more about it right now, but if you do a little bit of internet research, you'll come across some of these lossless compression algorithms, and you'll see how they work, how they achieve the compression without losing any data in the file. So to get that, if you just Google lossless compression, there's probably a great Wikipedia article on the subject. Okay, so so zipping files, again, this is often a way to achieve file compression, but the first tool we're going to talk about is a tool called tar. And then we'll talk about gzip and and bzip, and those are other commands for gzip and bzip are very much focused on compressing files. Tar is a little bit different. We'll get to that in a minute. And then we expand the files using some other commands, and we'll get to those. So we'll start with a tar command, and the tar command creates an archive. And the colloquial term for the archive is a tarball. So if you're talking to a crusty old Linux person, he might mention the term tarball. And he's talking about a file that is archived using the tar command. And tar, the original purpose of tar is not to compress files, but it's to collect a bunch of files into a single archive file. And the term tar actually is an abbreviation for tape archive. So this is from the days when you would back up your file system not to another hard drive or to a CD, but you would back it up to a tape. And this process was much easier if you could take your files and reduce the number of files, archive large numbers of files into a single tar file. And so that's where this tar command comes from. And then with tar, you can also add some compression. So if you use tar all by itself, we'll see this in a minute. If you use tar all by itself, you can create an archive without any compression. And if you use some command line switches, you can compress the files using a couple of different compression algorithms, bzip and bzip2. And so the basic syntax of the tar command is similar to other commands. You have tar, and then the options, and then the name of the archive, and then the files that you're going to archive. So let's take a look here. Options used with the tar command include -C to create an archive, -Z to compress with the bzip algorithm, -J to compress with the bzip2 algorithm, -V is verbose, so this will print a bunch of this will print information about what's going on to the terminal in case you want to get some more information about the execution of the tar command. And then -F is the file name of the archive. And if you use tar without any compression, you're going to get a .tar file. So that's and again colloquially referred to as a tarball, which is just sort of slang. If the tarball is also compressed, it will end in .tar.bz if it's a bzip file, or .tar.bz2 if it's a bzip2 file. Okay, so two different options for compression, bzip and bzip2. And what's the difference between those two? Well, bzip is sort of the first compression technique that the tar system used, and bzip2 is the evolution of the bzip protocol. So it's slightly more efficient, slightly better compression. But as a sort of a as somebody who's not creating huge archives, if you're just doing this to archive small numbers of files for yourself, then the efficiency of the zip algorithm is really not important. But the reason you need to know the difference between those two is that if there's some compatibility issue, like if somebody needs, if somebody's system isn't compatible with one or the other compression algorithms, you may have to select between the two. But for 99% of use cases, you can select one or the other of these pretty much arbitrarily. So when you do this tar thing, it's important to understand that all of the original files are going to remain in the directory where they're located. So you're not taking the files away and putting them in this tarball. You're essentially making a copy of the files, and that copy is going to be inside this tarball. Okay, so here's an example. So we're using the tar command tar-cf. So remember the C means compress, the F means the name of the tarball file. So files.tar. And then in here, we're compressing all files that have this format, right? So file and then star. And if you recall, the star means the star is a wildcard character. So anything, file and then whatever follows that, all the files that have that naming format are going to get dumped into this tarball. And then if you do an ls, you'll see that there's the files.tar thing there. So let's take a look at this. Oops. So I'm in my home directory, whoops, pwd, and if I do an ls, I'll see there's file 1 and file 2. So I'm going to say tar-cf files.tar, and the files that I'm going to put in that that tarball are of the format file star. And so if you look at my directory here, file star, the files that fit that naming format are file 1 and file 2. And so now if I do an ls, I have file 1 and file 2, and then I also have this thing called files.tar. And if I do a ls-l, this is interesting. So file 1 and file 2 are very small, 13 bytes each, but the tarball is a large file. It's not doing any compression. In fact, it's making there's a bunch of header data, and it makes a fairly large file. Okay, so I've just created a tarball. So if I want to create a tarball that is bzipped, I use the czf. I add the z to the command line switches. So again, C means create the tarball. F is the F has got to be the last letter in my command line switches, because the F has to immediately precede the name of the file itself. So and then I'm gonna add the Z, which means compress using the bzip algorithm. So if I go back here and I say tar-czf files.tar.bz file star. Now if I do an ls, I see that I have file 1 and file 2 are still there. There's files.tar, and then there's files.tar.bz. And let's see if that bz is any smaller. Okay, so the bzipped version of the tarball is much smaller than the just the regular tar version, right? So you can see it's a lot. The compression does a lot. Okay, and if I use the CJF option, then I'm going to end up with a bzip2 file. So I can say tar.cjf files.tar.bz2 file star. And well, now I have files.tar.bz, files.tar.bz2. Interesting, that size of that file is a little bit larger. The bz2 is a little bit larger. So now I have my archives. Okay, so now I've discovered how to create these tarballs. And again, what the reason for doing this is a couple different reasons. I might want to create archives that I can store, that backups, for example. I want to, if I'm working on an important project, I might create a tar of the current state of the project and save that. In fact, I might do that every day, right? If I'm a developer and I have a directory of a bunch of files, and I edit some of them, you know, on a daily basis. And I don't want to keep track every day of which ones I edit. I may just tar up the whole thing every day and store it somewhere else, so that if I realize, hey, yesterday I broke something and I need to get that, to copy that file back, I can open up the tar file. Another reason I might do this aggregation of files and or compression of files is so that I can send the file to somebody else, right? So if I want to send, you know, if I have a group of files, like a bunch of image files on my Linux system, I don't want to send all those images to somebody else via email or whatever. Instead of sending one file at a time, or instead of attaching a whole bunch of separate files to an email, I might tar them up into a single file and then send that to somebody. So tar command can be used to unpack tarballs that end in a .tar and to unzip files that end in tar.bz or tar.bz2. So the basic syntax of the unpack is tar.xvf. So v is, it means so X means untar, V means decompress if it's compressed, and F is the file. Oh no, I'm sorry. V is verbose, right? So V is verbose, and then the name of the tarball, name of the aggregated files. So I have all these tarballs now. So I'm gonna do this. I'm gonna create a new directory, make dir tar files, and I'll cd into tar files. Now let me move files.tar, files.tar into this folder. Is it there? Okay, there's my file. There's my tar file thing. So now I'm going to say tar dash xvf files.tar. So X is decompress, V is verbose, F is the name of the tar file, and it tells me, okay, now I've unrolled file 1 and file 2. So let's do an ls. Now the tar file is still there, but now I also have file 1 and file 2, and those things are both 13 bytes, right? So these are that. You've seen this before if you've watched previous videos. All these file 1 through whatever, most of them, you know, say hello world in them. Okay, so gzip is the other command that we can use. So gzip can be used to zip a single file or multiple files. Basic syntax is gzip, then the file name. The output of a file will have a gz extension, and the original file is going to be gone. So a difference with gzip is you're compressing the file, and the uncompressed copy of that thing is not going to be there anymore. So here's an example, gzip file 1, and so we'll see that. I'll go ahead and do this. So I'm going to cd, well, I'll do it right here. So I'm going to gzip file 1. Now I do an ls. Now I see file 1's not there anymore, but there's this file 1.gz. Okay, and the file got bigger. You know, why did the file get bigger? Well, I did this to a very small file, and there's always going to be some header data at the beginning of any kind of a zip archive. So, you know, the fact that I'm zipping super tiny files is what makes it look like the file is getting bigger. If I were to do this to a large file, then it would get smaller. In fact, if I were, let me try this, gzip files.tar. Okay, so here you can see the power of the compression. So I took this, so here I ran, so here's a large file. It's 10,240 bytes called files.tar, and I ran gzip against it, and now it's 168 bytes, right? So that file got a lot smaller, and the files.tar file went away. Now I have files.tar.gz. And so you might ask, okay, there are these different compression algorithms. There's bzip, there's bzip2, there's gzip. What's the difference? Why would I select one over the other? So here's the quick and dirty explanation. Bzip, again, is integrated into tar. So if you're going to use tar and you're going to zip the file after that, you might as well just use bzip because it's already there. bzip2, and that goes for bzip2 as well. So bzip is a compression algorithm. bzip2 is the evolution of that compression algorithm. If you have a choice, you might, I guess bzip2 is it's an evolution of the algorithm. So the expectation is that it's better. It's probably a little bit faster. It might compress files a little bit smaller. And then okay, so gzip. Why would you select bzip over gzip? Well, it turns out that gzip is a little bit faster, and when I'm doing this at the command line and compressing a single file at a time or a small group of files, the speed doesn't really matter because it's essentially instantaneous as far as I'm concerned. But if you're doing this to large file systems where you have thousands of files and maybe megabytes or even gigabytes of data, then the speed of the compression algorithm is, then it becomes an issue, right? So I might want to make sure that my compression only takes a few minutes rather than an hour or more. So the speed might be important. If the speed is the most important thing to me, then gzip is a little bit faster. bzip, on the other hand, has slightly better compression. So if my primary concern is the end size of the zipped content, so if I have a limited amount of space on which to store my backups, for example, then I may be more concerned about the size of the resulting compressed file, in which case I might want to use bzip. So that's kind of a high level discussion of which one is better. Okay, I can also keep the original file when I do the gzip. So I can say gzip-c file name. So that's the name of the file that's going to get compressed, and then I use the use the greater than sign to redirect the output of that into file name, and then I give it the .gz extension. So here's an example. If I say gzip-c file 2, and then I redirect the output into file2.gz, now when I do the listing, the original file is still there. If I'm going to gzip multiple files, then I put multiple files in the same line here. So I say, in this case, I say gzip-c file 1, 2, 3, 4, and then I redirect into files.gz. And then to unzip, I use gunzip. That's makes sense, I suppose. Gunzip. So gzip compresses, gunzip decompresses. So I just say gunzip and then the archive name. So now I can say make dir another dir cd another dir. Okay, now I'm deep in my file system. Now I'm gonna cp files.tar.gz to the current directory. So let me clear things up here. Clear, okay, print working directory, home student tar files another dir. If I do an ls-l, the only thing in here is this files.tar.gz. So now I want to unzip files.tar.gz. And now I have files.tar. And remember, when I want to unroll that tar file, I can say tar-xvf files.tar, get file 1 and file 2 back. And now I could, oops, cat file 1. There's my files. There's my original file before I tarred it and gzipped it. Okay, a lot going on there with the tarring and the untarring and the zipping and the unzipping and compression and the decompression. Again, use cases for this are, I want to back up large numbers of files into a single file, and I want to make it smaller so I can store it offline on some external media. That's a reason why I would use these commands. Other reason is if I want to send something to somebody via email or some other way, it's easier if I have a single file instead of multiple files, and it's more efficient in terms of network bandwidth if the size of the file is smaller. Okay, so thanks for joining, and now I encourage you to jump into the lab exercise. So teachers are going to have to provide that lab exercise to your students, and we'll see you next time. Thanks.